Breathing is something we rarely think about. We take it for granted. From our very first breath, provided everything is functioning properly. On a city street with heavy traffic, the air quality can be extremely poor, full of street dust, rubber, brake material, and rust. OSHA regulates the quality of air in the workplace through a system of enforceable permissible exposure limits, or PELs. On a construction site, these limits are often exceeded, leading to dangerous exposures to disease-causing dust. Inhaling construction dust can lead to a wide range of different diseases, which include pneumoconiosis and COPD. Silicosis and asbestosis are the worst forms of pneumoconiosis. Silicosis, also known as grinder's lung, is caused by inhaling silica, while asbestosis is caused by the inhalation of asbestos dust. It is not only the type of dust that determines the health risk. The amount of dust and the particulate size are also factors. The amount of very fine dust and the duration of exposure to a dusty environment. The size of the dust particulate is important because it affects how far down into the lungs the particles will reach. Dust particulate larger than 0.005 of a millimeter in diameter, or 5 microns, is known as inhalable dust. This is generally stopped in the upper respiratory tract, the nose, throat, and trachea. The body expels it mechanically. The smaller the particle is, the deeper it will penetrate into the respiratory system. Particulate smaller than 5 microns, known as respirable dust, is invisible to the naked eye and will penetrate into the deepest parts of the respiratory system where air moves very slowly. This makes it difficult to exhale the smallest particles. The dust particles that get lodged in the lungs are wrapped in nodes of scar tissue. This is the body's way of protecting the lungs. In time, this leads to pneumoconiosis, or COPD, which stands for chronic obstructive pulmonary disease. Some types of particles, such as silica and asbestos dust, cannot be broken down by the body, and they are sharp, which is why they go on causing damage even after they have become lodged in the lungs. It is necessary to wear a respirator when working in a dusty environment to avoid inhaling invisible, harmful dust particulate. Even better protection can be achieved if the dust is removed at the source and never allowed to reach the breathing zone. Dustcontrol has developed suction casings for most handheld and stationary tools, and often also produces custom-made suction casings. Tools with integrated dust extraction have proven to work best because the dust is captured at the source before it can enter the breathing zone. When the dust has been collected at the source, it must be prevented from being exhausted into the air in the working environment. A good dust extractor works in 3 stages. The first stage is coarse separation using centrifugal force generated in what we call the cyclone. After the cyclone, the air passes through a pleated fine filter which captures the vast majority of the particulate. The smallest particles are the most dangerous and have to be captured, which is why the final stage is an H13 HEPA filter. The H13 HEPA filter prevents the hazardous, invisible particles from being re-released into the work environment and entering your lungs. All of Dustcontrol's dust extractors are delivered with an H13 HEPA filter as standard equipment. So, to avoid long-term damage to your health in a construction environment, think about the following. Equip machines that generate dust, such as cutting and grinding machines, with suction casings. Vacuum clean regularly. Use dust extractors equipped with H13 HEPA filters. Use air cleaners for passive filtration of the ambient air. Try to find and use work methods that cause less dust. Use a respirator when performing tasks that will expose you to dust. Use only a NIOSH-approved HEPA respirator. A standard dust mask will not protect you.